Fluid statics and fluid dynamics, done by student Asad Bil Uthman. Fluid statics, a fluid at rest of fluid in motion where there is no or is assumed not to be a difference in relative velocity between the shear layers in the fluid. In a static fluid, the pressure is same in all directions. Classification based on physical properties. Horizontal motion. Translation motion is movement associated with the movement of an object from place to another, where each particle or point in the object during a certain time interval travels the same distance and shape of the path. Here is the example of it. The vertical motion is a vessel is filled with fluid, then the vessel is moved vertically with a certain force. Then the fluid is the vessel will get an addition or reduction of force. If the vessel is moved upward by force F, then the fluid particles will react in downward direction, thus increasing the weight of the fluid, as it shows in the pictures. The rotation motion. If a cylindrical tank is filled with the fluid and then rotated about its axis, the fluid will also rotate as a result of that rotation. The fluid particles get a centrifugal force in the direction away from distance from the axis so that the fluid in the middle of the fissure is pushed toward the wall, as it shows in the picture. Basic equations. Here are some basic equations of mass type. Derivative equation. Pressure in liquid fluid. The horizontal direction of pressure is the same, the force acting on the top plane as it shows in these equations. The example of the simple questions with its answer here. Example of complex questions with its answers. And the picture shows the example. Application of fluid statics in everyday life. Example of state fluid phenomena can be divided into simple, constant, and complex. An example of fluid at rest is simply the water in glasses water that is not subjected to any force causing the water to move. Another example of a stationary fluid that is not simple in river water, which has uniform velocity of each particle in different layers, from the surface to the bottom of the river. Fluid dynamics. Fluid dynamics are sub-disciplines of fluid mechanics that describe the flow of fluids, liquids, and gases. It has several sub-disciplines including aerodynamic, the study of air and other gases in motion, and hydrodynamics, which is the study of liquid in motion. Fluid dynamics has wide range of applications, including calculation forces and moments on aircraft, determine the mass flow of petroleum through pipelines, prediction weather pattern, understanding new flow in interstellar space, and modeling fission weapon detention. Classification by viscosity. Emphasized fluid. Emphasized fluid flow in is a flow with zero viscosity or considered to be zero, or flow in which the shear stress difference between layers of fluid is zero, which is the vertical velocity graduation no longer exists. Viscosity equal to zero. The difference in shear stress between fluid layers equal to zero, as it's shown in below picture. The viscous fluid. Viscous fluid flow occurs when the exact velocity in stationary solid surface is zero, or it can be said that there is no slip on the surface on object where the fluid flows, which is no slip condition. Accurate velocity on stationary solid surface equal to zero, no slip condition, as it shows and explained in the picture. Laminar flow occurs when fluid particles move along path barrier to adjacent particles, and the example is shown down below. Turbulent flow occurs when fluid particles move in highly irregular or random trajectories, as it's shown below. Steady stream. Steady flow occurs if, at any point in the flow velocity doesn't change with time. Unsteady flow. Unsteady flow occurs when a flow velocity always changes with time. Mathematically, unsteady flow is written as the equation. Uniform flow. A uniform flow is a type of flow and the flow velocity along with the flow is the same as figure A. Non-uniform flow. Non-uniform flow occurs if the channel area changes so that speed in one place is indifferent from another, then the flow is said to be non-uniform mathematically. Non-uniform flow is written as the equation in the figure P. Compressible flow. Fluid where density or mass density can vary. Density increases when it's under pressure and decreases when it expands. A fluid which, when subject to pressure, the change in mass density is so small that it is negligible and is considered to have no change in density. All is shown in the figures down in the right side. Internal flow. Fluid flow is limited by the surface of the object or casing. Therefore, the boundary layer cannot expand without being constrained by the surface. External flow. Fluid flow that is not limited by the surface or the object, but as if the surface of the object is limited by the fluid flow. With this unrestricted, the fluid flow can move in straight line without being obstructed by the surface or the object, as it's shown in the figure right. Basic equations. Here are some basic equations: the continuity equation, the debit equation, and the Bernoulli's equations. And down below, it shows the figure. The basic equation, horizontal leaking tank, as description down below, with the VHXTH, which determine the V for velocity of liquid exciting the hole, H for distance where the liquid soil falls to the leak hole, X for horizontal distance the liquid falls, T for time it takes the liquid to hit the ground, and H distance from liquid surface to the leak hole. Example of the simple questions. Here are some examples with its answers as it shown in the figure. And here's another example of complex question with its answers. Pump installation is structured as shown in the figure below. Application of fluid dynamics in daily life. Fluid dynamics provide method of studying the evaluation of stars, ocean currents, weather patterns, plate techniques, and even blood circulation. Some important technological application of fluid dynamics included rocket engine, wind turbulent oil pipelines, and air conditioning system. Thank you so much.